And in the past, we used to have here a very clear software behavior that was really predeterministic. Here we need to find some new ideas, some new models on how to do that when an artificial intelligence is used, where by definition the system might continue to learn over the time. And here we need to find some new paradigm to validate such type of application. And here especially, I think it's key to really well understand the data and to have that as a basis to have a successful validation. So now enough from my side. I would like now to hand over to Rolf. Rolf, are you here?
Yeah, good morning, everyone. I will share my slides. Give me a second. So, can you see my slides?
Yes, yes.
Very good. So, hi everyone. It's an honor for me to be a speaker on this breakfast session, and to be honest, I would prefer a dinner talk. It's a little bit early, but so what? I will do my very best. We want to talk about AI applications in pharma, applications using artificial intelligence, and whether or not we can trust those applications. You know, in the meanwhile, we have many examples of AI in our daily life. But if you want to use it in pharma, the big question is, how can I validate an AI application, or more precise, what do I have to do in addition when using AI algorithm, or we call it AI models? So we have some ideas. I want to present these ideas, and we have a running solution for a certain use case, and I will present some theoretical aspects and the real use case, and we hope very much for your feedback. You know, AI applications have a special characteristics. Decisions are based on probabilities, and the question is, how do we need to deal with this? We would like to know, are we on the right path? Does it make sense now, or is it too early? So these are big questions we have to answer. Maybe first, sorry. There's one slide missing, sorry. First of all, a short introduction from my side. My name is Rolf Blumenthal. I've been with Verum for more than 40 years. The reason is I'm one of the co-founder of the company. But by the way, you see the Körber logo. Verum is now part of the Körber company. It's a company based in Hamburg. It's a collection of 160 companies in different business areas. And our brand name is now Körber Pharma, together with other companies like Seidenader or Dividella. It's a packaging machine company, or inspection machine companies. So yes, around 8 companies in Körber Pharma, and try to offer a bigger solution, not only machines, but in addition, some software as well. By education, I'm a mathematician and computer scientist. The reason why I'm telling this is the fact that we started a new division 5 years ago, a divisions which deal with the use of data from pharmaceutical companies. You may know Verum has an MES system, a PassX system. We are more or less one of the leading companies in the world for MES systems in pharma. But for this new division, we have now new stuff, data scientists, data engineers, and so on. And with my big knowledge from pharma, I'm more or less a translator between pharma business and data science. So I think this is one of the first main messages. You need to have, for AI applications, you need to have new stuff, new skill sets in your company, and maybe a new mindset as well. So here on the slide, you see my key messages at the beginning. We have some good ideas how to validate AI, and we have some practical experience with a use case. The nature of AI is special. That's a challenge. The result of an AI application are only correct with a certain probability. So, for example, a valid result of AI is the following. The AI predicts a production of 1,000 kilograms in a range of plus minus 5% with a probability of 95%. So do we accept such a result? How can we verify this result? These are the questions. So we need controls that we can trust an AI system. But we have to convince our customers, you, or all the participants here, and also the authorities. So we need a new way to generate this trust. Good news are we are not alone. We have co-founded a group that is addressing this issue. The group includes all stakeholders on this topic. So any recommendation or guideline from this group would be a great advantage on the way to validate AI applications. One of our customers provided us a huge bunch of historical data and a certain use case. And we are happy to announce that we have developed an AI application for this use case, and it is running. And we are presenting this use case briefly at the end of the presentation. In addition, we have already been able to implement almost all the validation principles defined in this group. So we can directly show how it is working. So let me first explain again the real problem of AI. In traditional software, there's an algorithm that was developed for a specific problem. This algorithm is comprehensible and can be verified at any time by recalculation. We call this a white box approach. In the black box approach, this is the AI. Here's a case that the algorithm delivers a result only by learning. The algorithm can do nothing at the beginning. It is trained with data. It uses historical data to define a generalization. So if the algorithm has only seen enough cat pictures, it can recognize cats, even if they have a different color or larger ears. But again, only with a certain probability. Pavel, the next speaker, will talk about some difficulties doing this. And it can recognize dogs only if it's trained on dogs. So what is not trained cannot be handled. Somewhat similar to human learning. When an operator makes a decision, it depends on his knowledge and what he has learned. To create more trust in the pharmaceutical industry, we have the 4 eyes principle. And that's why you can ask the question about the trustworthiness of AI by asking, what is the 4 eyes principle in the use of artificial intelligence? Sorry. Something is wrong here. Now it works again. Sorry. Can you see my presentation?
Yes.
Yeah.
Yes. Slide 4.
It's sometimes becoming greater here. Since I'm also a co-founder of the GAMP forum and a member of the steering committee. There, I passed this question on the GxP forum, and we started a working group in 2019. There are 22 members in the group, representatives from the pharmaceutical industry like Bayer, Boehringer, Novartis, or Merck, representatives from suppliers like me, consultants, and also very important German inspectors. And just some weeks ago, we presented our results to an ISPE special interest group for AI validation. They were very impressed by our results, and we are invited to work with this group in the future. This is really a big advantage that the results are accepted on an international level. In their group are some inspectors from the FDA. The goal of the GxP group on AI validation is the development of a document that will help all parties involved to assess the question, can I trust AI application or not? You can see on the right side an extraction of the content of the document. For example, we have a chapter that describes the elements you need for an AI application, a chapter that explains the extended product lifecycle, the development lifecycle for data-driven software. And one key chapter is a maturity model for AI applications. So in the next minutes, I would like to explain shortly what we have discussed in these three chapters. So first of all, the elements you need for an AI application. So you may know this principle. First, we need to define and build an AI model before we can use it. There are different algorithms to approach different problems. Do you need to find a cluster? Do you need to find a relationship between parameters or the result of the process? So the first steps are to select the right model and train it. You first need to get the historical data for training. So you need a kind of ETL functionality. ETL means extract, transform, and load. So to get the right training data, and here is a critical step. You have to take care of the data. So there are missing data, maybe incorrect data, or it was very important, the bias that lead to a wrong training result. So it's a standard today to subdivide the data set in one for training, one for verification, and at the end, one for testing. But before you can do the training and testing, you need the right algorithm that fits to your problem. It often starts with some tools to look deeper into the data to find some relationship. If this is done and you know the direction, then you can define what algorithm fits best to your problem. Is it a regression function, or is it a decision tree, or it's a neural net? The next step is then to train such a model with a training data set. And in the verification step, the trained model is tested with the verification data. This test compares the results of the model with actual values in the data set. And then you can calculate a KPI for the model quality. This phase is very agile. It could be that the training and verification is repeated several times with changed parameters or changed algorithm until the result quality is according to the requirements. A last test is then done with the test data, and at the end of the day, you have a trained, verified, and tested model that can be used now in operation. In summary, you have to take care about the input data, a suitable algorithm, and the result of the quality. the quality of the result. So now we are ready to use a model in an AI application. We distinguish between the model and the application because in reality, you need a lot of software around an AI validation, an AI model, like getting the data, showing results, and so on. Again, we need an ETL functionality to get the data in operation. But now we use the data as input for a model to get a result, to predict or to decide. Here we have to take care again that the input data are okay. Missing data, wrong data, and so on can lead to a wrong result. So we need to have in the operational phase a kind of monitoring of the input data. Then we will get a result. And we can now check the quality of the result in this moment. We cannot check the quality of the result in this moment. But what we can do is to compare the predicted result, with, at the end of the process. This check or monitoring will give us an indicator whether the AI application is running properly or not. If a trend can be recognized that the result quality is going down, a retraining could be helpful. After some runs, there could be a change in the process. We need to address such change in the model by retraining with the new data in addition. So, and we need a development life cycle, or we have looked on the development life cycle for AI. A typical life cycle model for AI models is shown here as a circle. This model is known as a CRISP-DM model. This is a cross-industry standard process for data mining. And it's known as this CRISP-DM model. The model shown here is even more detailed and shows, besides the normal routing along the circle, some places with cycle patterns and repetitions. This shows here how agile the determination of an AI algorithm and the training by data actually is. Let's take a quick walkthrough. So we started with a certain use case. We have the user requirements. Then we have a step for process and data understanding. This is really important here. Then I mentioned it before. We have the model selection, training, verification, and there's a circle with an optimization. We have the model test. Then we have to integrate the tested model in an AI application. We need a classical validation of this AI validation. Then we use it in operation, and in operation we have to monitor the input data and the result quality. So the first challenge is to determine a proper model. Data scientists often start by taking a closer look at the data, and only when correlations are recognized do they look for a certain suitable algorithm. And often the first attempt does not lead to success. And the search for a suitable model continues according to the trial and error principle. So this is the first circle again. And the second important cycle is setting the right parameters. Training and verification runs with varying parameters can determine a system with good results. Very often it's a kind of experiment to find the right model. So you know this from process development in pharma, these experiments, the design of experiments, and here's a little similar. So you have experiments to find the right model and parameters. And we have seen this is followed by a classical validation of the whole application, and important at the end is the monitoring of data and results. This picture shows the same, but you know, no GAN presentation without a V model. I tried to map the cycle model to the standard V model. To show here how the AI life cycle model fits to classical validation, I mapped all these steps. And the inner V is a classical approach to create software. We all know, if we are using agile models, that we need many repetitions and cycles in this V model, but it's a classical V model. The AI model activities are in the outer V, and you can see here the steps in the circle again. To define the use case, to understand the data, to find the model, and so on and so on. And the repetitions are shown as well here. At the end of the day, it's important to show here we still have a classical validation. And the main steps in data-driven software are the definition of the model in an experimental form on the left side of the V, and the monitoring of input data and the result quality in the operational phase. So the main result, statistical validation, is not enough to trust AI validation. You need to add on some monitoring in the operational phase to really create trust. A third part of the document we are creating in this GAMP group is a maturity model. This is one of the most important elements of the guideline. Here, depending on two properties of an AI model, it's shown which degree of validation is necessary. This means additional validation in addition to the classical validation. The two properties are the control mechanism of an AI system executes, and the autonomy of the AI system. So we have defined a number of stages or levels for those properties. The level of control mechanism are, so the system is used in parallel to a normal GMP process. So the second is the system is executing as a GxP process automatically, but must be actively approved by the operator. The next stage is the system executes a process automatically, but can be revised by an operator. And the last one is the system is running automatically and controls everything. Yeah. And the levels of autonomy are on the stage 0. We have no machine learning, it's a fixed algorithm. Very often AI fixed algorithms are recognized as or seen as an AI application, but it's not an AI. We are talking about machine learning. The next stage is the system is just in a locked state. Updates are performed manually by retraining with a new training data set. Next step is updates are performed after indication by the system with a manual retraining. So the system itself detects that there is a retraining is necessary. Next step is updates are performed by automated retraining. So the system is doing the retraining automatically with a manual verification step. And the last two steps are that the system is at the end fully automated, it's learning independently, and it's a kind of continuous learning with each of the data that are coming into the AI application. And with this definition of control, design, and autonomy, we defined how to validate an AI application. I don't want to go into details here. At the end of the day, we created validation categories and mapped them into the metrics to determine and to scale the scope of necessary validation activities. In the matrix, we distinguish from no validation required up to classical validation with many additional steps. You can see in the last category, the 6, today we have no way to validate self-learning AI application. That's very clear. Here we are in the area of continuous learning systems. And with each additional piece of data, the system gains more knowledge. It seems like an idle situation to always be at the highest level of knowledge, but we cannot predict the quality of the result. We cannot predict the quality of the result. There is no evidence that the additional training leads to a better knowledge. So we have discussed this category with a group of German inspectors, and it's pretty clear they want to have a trained system with stable results. That means the same input produces the same output. And continuously learning systems do not have this property. Maybe in 5 years we are in another situation, but today this is the situation we have. So this is the end of all the theoretical aspects. Now I would like to show you a use case. When we started our new department I mentioned, I asked some of our MS customers, please give us data supporting us to get experience in data science. We got many historical data from a biopharmaceutical downstream process. It's a chromatography process, and we started to look into this data. By the way, on the right upper corner, you can see the life cycle circle again, and an indication where we are in this life cycle service. So it's for your orientation. We are now in the use case and the user requirements area. So here you can see the results. The customer uses 4 columns with resins in it to separate a bioliquid coming from the fermentation into an API and other byproducts. The small picture in the middle shows the principle. The goal is to get only the yellow liquid here. Depending on the material flow, product A is received first and then B, C, and so on. An operator controls when it is the right time to switch from the bad to the good product and vice versa. And the big goal was to find a technical solution that supports this decision. Why would a support be very helpful? It is helpful because the operator sees some information on a screen to do this decision. Curves which shows the concentration of the API and all the byproducts. Measured at the outlet of the column during one batch. You see here a process flow of typical batch. The dominant orange or yellow curve is the API you want to extract. And the others are the byproducts. If the operator would see the complete process, it would be easy to decide when to start extraction to get the biggest cake out of it. But he sees only the data on a certain time, and when he needs to decide, there are not too many data on the screen. With his decision, he controls the yield and the impurity of the output. Starting too early could result in too high impurity. Starting too late could result in less yield. His decision is based on his experience, on his behavior, maybe too cautious or too brave, and can vary from day to day. So you need to know the future. You would need a crystal ball, and there are a lot of variations in the process that makes life not easy. The screenshots here on the right shows curves from approximately 300 batches, and there are a lot of variations in it. So the idea is to support the operator with some software that predicts a further process flow. Instead of using a crystal ball, we want to use AI to know more precise what happens in the near future. Is the API concentration increasing high enough in the next 30 minutes or not? In most cases, the optimal extraction start is around 500 minutes after start. So the idea is to predict at 400 minutes how the curves would look like. And it works. The results are pretty good. When verifying the trained model, we can check the quality of the model. And in the scatter plot on the right-hand side, you see that it's pretty good. All dots that are on the right side on the line are predictions better than the human ones. So for the process and data understanding, at the end, we had 12 time series, concentration values of the different materials from an automatic HPLC device, concentration values from a polarimeter, and the material flows values. And we have some metadata like limits for impurity. These are all data for data-driven software. All curves are going into the model, and all curves are predicted as well. And the process itself has variations based on aging of resin and small changes in the process parameters. So at the end, we got 10 years of data, and it seems that the data contains the complete knowledge about all situations. So what are the next steps? With all this historical data, we created a model to predict all curves at process time 250, 340 minutes. Based on this prediction, we calculate the starting point to achieve optimal yield with acceptable impurity. To achieve this balance is the main goal of the model. This information was used to inform the operator at what time he should switch from bad to good. Until now, the software is only notifying the operator. The goal in the future is to start its extraction automatically. To bring you back to the maturity model, with this approach, we are in the situation that the validation is not necessary, the additional validation. The operator is still responsible, has to decide, and can simply overrule the AI model. To go to the next step, we need more experience with AI and a broader basis of understanding and acceptance. Then the system can control the process and make decisions without any operator. And a higher category of validation will be necessary. To show you again how it works, we are able to calculate exactly at what time the best yield could be achieved with acceptable maturity. The vertical lines you see here on the screenshot are the lines with the limits of the byproduct. If you are behind the line, the right-hand side, then the result of the batch will contain acceptable quantity of this byproduct. So not too much. If all byproduct limits are passed, we can start extraction. Important is the delta between the optimal starting point and the actual starting point here in the historical data. We were able to calculate cutting always at the best point, you could achieve 1.5% more yield in the average. It seems to be a small benefit, but looking on the absolute quantity of the additional yield, it is really a great benefit. To be honest, this difference is between best and actual, Important at the end is how much yield it can be produced when predicting the starting point. And our experience so far is that we are on the level of 1%. So with our prediction, we are 1% better than the manual decisions. This is less, but still beneficial. And this benefit is achieved without any expensive equipment, without new equipment, without changes, only with software. Remember the steps in the life cycle. We are now at the step to select a model. I want to show here there are so many methods and algorithms available, whether you need a correlation analysis, a regression calculation, or cluster analysis. There are a lot of methods, and all these methods are available as open source software or executable on a platform such as Amazon or Microsoft. And even if you have chosen a neural network as an example, it is still a challenge to decide on a suitable network. So the variety of neural networks is simply very large, and it requires expert knowledge to decide on the right network. Based on the use case and the data, a data scientist uses various methods and algorithms. Only when correlations become clear and are relevant to the use case, an AI algorithm can be chosen to create a suitable model. So a very important message for you is you really need the experts for choosing the right model.
Rolf?
Yeah.
Just timekeeping, were still many slides to come, or?
Maybe 10 minutes, is okay?
We are already 5 minutes ahead, but...
Okay. Okay, I will hurry up a little bit. After many trials, our data scientists today decide for a neural net. And we decide for LSTM net. It's very suitable to handle this time series and graphical data. And it's able to keep historical data. So the neural net is constructed similar to a human brain. We have neurons, and we have links between the neurons, and your neural net has to learn before it can do something. But you can influence its training results with many parameters. And I want to show you here, this is the next challenge, to find the correct parameters and to train the model. So only here some facts. We have 200 training runs with varying parameters to find a good parameter set. The parameter sets are, we have 4 inner levels in addition to the inner input level and output level. We have 32 neurons on the level, and we need 1,000 iterations per run to train the model itself. And maybe one important key indicator is the MAD, is the mean absolute deviation to define the distance between prediction and verification data. This is very important that you have a KPI to define the model quality. I want to show you very short here how we train this model. You see here all these curves, and you remember we want to predict at level minute 400, and we subdivided all these curves in curves from 0 to 400 and 400 to 1600, and we trained the model. If there is a curve from 0 to 400, the 400 to 1600 will follow. So this is the training method. There's a left side of the curve will follow the right curve. This is what we trained here. And we used the same principle. We used other curves. You remember the verification process. we used verification curves to compare the prediction with the verification data. And again, this scatter plot shows you we were able to be very near. The distance was very low when we trained this model here. So I'll only show you how precise this trained model is. You see here the actual curve, the black one, and the predicted curve, the red one here. So it's very, very similar. Can you use it for all the calculation of the numbers we need here? And then we use it in the model in an AI application. You know, we need the data acquisition, the dialogues, and so on and so on. And this chromatography application is now used for 1 year, and we have very good results. And at the end, I want to show you some screenshots here. So the operator itself sees only this very simple dialogue. You see the 4 columns. You see the 4 columns here. You see the main values all the columns. On the left-hand side, the process is finished, and the 4th column, the process is running. It will end up in 6 hours. And you see here on the below all what we are calculating.
Rolf, we don't hear you anymore, I think. You are muted.
Yeah, we lost.
I think it muted you somehow. I see the mute icon. But...
Rolf, you're on mute.
Yeah. No.
Sorry. sorry so much. What do I have to explain again?
Yeah, just the last sentence, I think.
Okay. So you can see here the screenshot, and it's only to give you an impression. So if there is the moment that the operator has to switch from bad to good, he will see a notification here, and this is very simple for him. But if you want to need more information, he can really click on one of these columns and will see this kind of process flow. And I think this is important again, because you need some transparency in the process, and you need transparency in the information the AI system is producing. So the explainability is one of the big key points to trust in the AI. Yeah? So, and we put in, I talked to you, we have some methods to check the input data. You see here some notification.
Sorry, Rolf.
Yeah.
Are you sharing something? Because
sorry,
you don't share anymore.
Sorry. Everything is wrong here. Sorry so much. No, wrong. Sorry.
But we don't see the slides. We see just the video.
Yeah, sorry. Oh. It's no, so now you see the slides?
Now we can see it.
Okay, yes.
Okay. Again, sorry. So So you remember we are the incoming data, we have to monitor this incoming data, and we are checking this data in the following way. We are creating so-called training corridors. So these are all the data from training, and if we get an incoming data that is not in this training corridor, the probability that we cannot get the right prediction is very high. So as long as all the data in the corridor, the prediction is very good. And you see here some notifications, some signs. We have this input monitor, and we are checking with thresholds if data is outside the corridor. And you see here in the middle, so the dotted line here in the middle is a prediction. The dotted line below and above are the corridor, and the other line here is the actual value, and here in the middle it's outside the corridor. And this will lead into some notification for the operator. And we have some kind of thresholds. You can define how many corridor validations you want to have until you stop the prediction and will switch over to manual activities. And the last one is the monitoring of the result quality. You can see here the KPIs I mentioned before. Are we above or below the prediction? Is the prediction better than the best value? And if you have a trend here, then we are indicating a retraining. So this is more or less the end. The summary: to create trust in AI, you need more than a classical validation. The quality of data is most important. You will hear from Pavel, there is a Danish inspector. He has created a checklist, and most of the questions of the AI application checklist is dealing with data. And the AI model validation is focused on model selection and training, and the real-time monitoring for the input data and the output data. So we have seen, we have ideas, and we have already implemented them to create a better understanding, but we are at the beginning. So we still need a broader community accepting a validation approach. And you are all invited to join the GAMP community. It would be good to have more experts there to create this GAMP guideline, so that we have at the end a good and a good basis for this broad community. So thank you very much.
Thank you, Rolf.
And sorry for the inconvenience here.
No problem. Pavel, are you here still?
Sorry?
Are you here?
Yes, I'm here. I'm here.
In the meantime, Rolf, you can see there are a couple of questions on the chat. Maybe you can answer. Some of them are easy, I think, to answer by written form.
So it's on your side.
So should I start or?
Can you start? Sorry, I thought you were trying to share.
All right. Yes, I'm.
Page is yours.
All right. Just let me know when you see it.
Your screen, yes, it works.
All right. So my name is Pavel Dobratsky. I work for Roche, and I was asked by Christoph to join your breakfast and talk about AI in GxP environment. Actually, it's more in a regulated environment. My main work was focused on PV, which is pharmacovigilance. Some may know as a drug safety word, which is also a very big world. but the adoption of the AI and the work that was done here can be easily adopted to any other areas like GMP including. First, the important note that I need to give to this community is that I'm a Roche employee, and Roche is a member of Transaccelerate. Transaccelerate does not endorse any vendor, including Vega. And I'm not representing right now the Transaccelerate here on this community. Rather, it's me asked by Christoph to join this breakfast and talk about AI and what I know and what I can share with you guys. So I'd like to start maybe that AIs are already everywhere. I mean, you may not notice. I mean, there are a lot of people that don't know even where AI is, and there are like very raw examples, like on under our phone applications in the photography to change the photos, to steering some drones, advertising. Like lately, you may see some deep fake examples about test reading and analyzing, also test generation. One of the example is like in let's say newspapers, you can generate a small text from the vast of information that I can get. The Boston Dynamics examples, the funny robots that you may see on YouTube, for example, and the military application at Tesla and lots of other things. But for us, it's most interesting are those, let's say, regulated somehow, like in the pharmacovigilance or software as a medical device, or in the GMP, like in the manufacturing. And maybe before I jump to other slides and give you some information that I gather and try to squeeze here into those slides, I need to give some like general assumptions on the AI, right? So basically, you need to be aware that AI usually solves a target, a simple problem that you can get. It's not like artificial intelligence that, you know, it's a brain that can solve many problems. It's always like recognizing the thing from let's say 2 or 3 different categories, or classifying and get those categories. So it's always like a simple problem, simple step. Like even in the example from the presentation before, it's not AI that will run entire manufacturing, right? It's solving only one problem, when to start extraction. That's worth to know, because when you think and hear artificial intelligence, you instantly have in mind like big brain that can do lots of interesting stuff. There are some solutions like IBM Watson that are worth to explore, but still it's not as artificial brain. And usually AI is a module, is a part of another IT system. It's also worth to know, because you always need somehow interface to a user to show him a data in the understandable way, like light traffic bulbs or some numbers that he can understand and can react, can monitor those numbers. So in terms of validation of such AI, it's not only about this AI module. So working on AI module is one thing, but validate entire system with this module, and maybe with many similar modules in different steps, then that's really a tough task. So don't expect one slide solution for validation. I mean, I'll try to squeeze and show you maybe 1 or 2 pictures when you can have some focus points that you may consider as like a one slider, but it's much more. And the key message I think I'd like to share right now is that you need to build your knowledge and standards in your company in terms of your business, your area of interest, and so on, because the AI, like already solutions, publications, and all that Internet of Things, there are lots of information there, but where to start, how to start? I think one of the best way is just to start, like make a first step, and while doing the first step, just gather the knowledge. create a guideline, a standard, a web page, wiki, whatever else, but just start gathering this information so we can share across the team, and maybe across the entire department and so on, so we can grow with this. And about AI, like there is a, I could say, business expectation or some kind of like a marketing promise that AI will solve your problems. It's not true. And most of the time it requires a lots of investment on the beginning, like a lots of, like, you need to acquire data, you need to clean a data, you need to work on data, you need to have like 20 cycles of training of the model to pick the right model, right parameters. So it's not like you're doing this once and it's working, right? You need to do it several times till you are comfortable enough to move forward. But even if you move forward, you don't have this sure that it's working as you expected. I mean, it may looks, but not always you know as it truly is. And about the trust, I think that's the key element to trust AI. And one of the way to gain a trust is explainability of the AI. So how the decision was made, based on what we can build a trust. Of course, there are other factors like the time that they're using AI. And as long as you are using AI, you know, through the time you gain this trust, right? But till something bad happens, you lose this trust and maybe you will never trust again, right? So how to build good AI that the trust can be built and people can trust more and more, especially in a regulated area when your health or even life can be put in a, let's say, artificial hands. And one of the key assumptions also here connected to building knowledge is to do the readings. There are lots of good materials starting from web pages, posts, blogs, publications. Read. That's I could say it's even disadvantage because when you try to search something, there are so many results that you don't even know how to focus on and how to read all of those materials. But despite even that fact, I'd like to also encourage you to read the references to the interesting materials, because there are lots of knowledge that people gain through those references they have on the end of the materials on the papers, to gain the knowledge and write in a, let's say, even different words, or combine the knowledge from different sources. So what are the challenges, and related to that, a key focus points, I could call it like them. And maybe I can start with the, let's say, like small differentiation between rule-based software, where you have the even mathematical rules. You may have a data and you have like traditional programming, so you can put the mathematical rule, for example, a plus b equals c, so you have an answer, and you can apply this everywhere, and whatever you do, this mathematical rule will always work. So it's like a white box, as Rolf showed you. But in terms of AI based system, it's a little much complicated, because all of the, let's say, rules, everything lies on data. So it's like data driven. You have a data, and from the data, you do the data science, and then you have some rules and maybe some answers to your questions on the beginning, like what is the correlation? Can AI help me to find the right moment or a right answer or right areas to search for more? Depends on the solution, right? But that's the main differentiation between rule-based software and the data-driven, which is like AI. And what are the, I could say, challenges, especially when you compare AI to rule-based, because we all know the rule-based systems. It's like lots of years of experience and knowledge and regulations and everything that we gain through all those years. And within the AI, mainly we based on proof of concept, proof of values, maybe small solutions. It's not yet so so big enough, I could say, that all of us understand this well. And the let's say, a first differentiation and also a challenge is that the answers from AI, it's not deterministic. It's not like yes, no, it's equals C, because you always have some kind of probability. I will show you some examples later, but because of this is only a probability, like it's a 90% a cat or 60% of dog. So what does it mean? You may apply some a function that can, read this, and if you reach certain threshold, it will say yes, that definitely dog, but still underneath it will be like 90% it's a dog, right? So one of the challenges that the answer is not deterministic. So how to read the answer, how to take actually some actions based on some probability. The other factor is that some development, let's call it like that, practices to building AI are still under being built, right? So how to include explainability from the scratch, from while you are building the AI, how to put on top, let's say, natural network, some additional things that will give you this explainability. So in the end, you can give an answer. It's not like 90% of a cat, but it can actually shows you, maybe visualize why the answer is based that this is a cat or dog or something else. And additionally, it's like quality practices in terms of like testing. In some place, I will use like sometimes testing, sometimes data science, because actually a data science team is consist of many skills, and it's not simple like manual testing that you may know from rule based. So again, additional this practices, the knowledge that the people must gain. It's also not like set. It's not so much explored as for rule based, and those are being still established. People are still learning and trying to get the knowledge from communities and other places. Having AI, you may expect few solutions on the production, because if you build one AI that even gives you an answer, sometimes it's a one AI within entire a system, but may also be that you have a system which have underneath few AI solutions modules, and they may even let's say fight each other for the answer and give the operator the answer from different methods, different modules inside. So the operator can decide himself, having different source of the information from different modules. And that may be really challenging in terms of testing such solution. Not saying even about the validation, it's also a challenge here. So the complexity is very high. And our experience, it's not so good, as I mentioned before, because mainly in terms of AI in regulated environment, we are in the matter of like proof of concept, maybe proof of values. Some of the companies not yet implemented those solutions. Maybe they consider, but maybe it's one of the good place to start, like to play around. Okay, we have a lots of data, what we can do with that, right? And see the results, and then just improve through the time. So gather the resources needed to that, gather some lessons learned from those experiments, and then maybe write a new like a standards or practice or wiki page, whatever else, just to just start noting this knowledge, so you can actually gain this knowledge and have more knowledge management in terms of AI. So few focus points here are like focus on the testing process. Do you have any applicable procedures and standard how to deal with the testing, deal with the data with some methods? It's not, again, a manual testing, as you know from the rule-based testing, right? And build the actually these data scientist knowledge here. Build the competencies, because it's not always like testing how to break things down and find the errors, but also it's terms of like test automation, using a tool for test automation, maybe knows and understands the differences between coding in R language and Python and the entire ecosystem of the tools that supports that, right? Because Python is cheaper than the R solution, right? But the R solution provides more in terms of a tool support. Advanced analytics, something again that your people need to learn and understand. So build actually capabilities within the data scientist team to make it possible to use AI, test AI, and later on maybe validate entire system with the AI. You need to think about tools unification. There are actually two, I could say, different stories. One is like a tools for entire solution, like using DevOps tools to automatic deployment of the solution and so on. So like from the development or entire project perspective, and then like a tool set for design, but for data scientists, like how to handle this automation, how to handle data sets management, because as Rolf showed you, there are at least 3 different sets of the data, how you manage them, how you version those data, how you clean or improve those data, right? How you even pick which of the data should be used for this training iteration or another, or if you do you using any random selection of the data, or you have fixed data sets, how you keep those data up to date after a while, right? Building teams, so it's like a technical teams and business teams, and maybe you can add any, let's say, compliance or quality teams to that. You may have a vendors which with whom you need to work on, right? So having those teams, it's also very tough job, because they need to understand each other. Even like a glossary should be the same. Sometimes you hear that there is a model verification, sometimes it's a model validation, and sometimes you have a validation from the perspective of entire system, like a processes. So whenever you hear validation, may not necessarily mean the same thing for different people, right? So you need to build the teams, and they need to understand each other, including a glossary, and they need to communicate well. So it's not like someone at the business saying, okay, I need AI which is doing something like a use case and nothing more. Their heavy involvement must be in the building of AI. And I could say it's even more than with the rule-based testing. When you can give a rules, like mathematical rules, developers can build a system, and you test it, and that's it, it's working. Whenever you apply, it's working. With the AI, it's totally different story, because it may work on a test environment, but when you apply this to the production, it may not. So you must put a lot of effort to make it working, or make it works. And the last focus points here in terms of testing, but it's not like delete. I mean, there are, of course, lots of more areas to focus, but the last that I have on my list is like requirements and risks. And I have one of the example here, like, do you know exact user needs? It's correlated to the building teams, but one of the example that we had one day at Roche in terms of building chatbot for patients. So we tried, I think, 4 different technologies, try to build in the very small time during some hackathons 4 different solutions and compare them each other and see which works the best. And the idea was that the patient can talk with the chatbot and answer some questions that usually are filled in on the paper, like, how do you feel today? Did you take your drugs? And so on and so on, right? So there is a, let's say, questionnaire, and that questionnaire could be implemented in the innovation fashion, like have a mobile app, and the app will ask you a question. So we instantly learn new user needs from this example. And what struck me from this example was that patients sometimes feel bad during the morning, let's say, routine, and they don't want to answer loudly on the questions from AI that, I feel bad today because their family is listening, right? So there are additional challenges, additional needs from the user. Not only like we as a business, we know something and there are technical guys that can implement the solution, but there are also lots of other factors in terms of end users that you need to take under consideration. So I could say there are a new set of new requirements and risk that you must apply to your AI, right? And of course, additionally, the validation verification, maybe UX to use on the solution as an entire system, and how to build a trust and how to implement this trust maybe from the very beginning. And regarding data science, like a life cycle, I could say it's something that some of you may already know. It does not look very complicated, but it's worth to mention about those steps. So first, you need to acquire a data, maybe acquire even data from different source, and you need to select those data from those sources to have a right set of the data for your solution. Then you, let's say, pick up the model parameters, you build this model, you have some output from the model, and then you can apply this to entire system or application, and then have a monitoring during production. Looks simple, but when you add all the additional tasks that must be done here and additional arrows and cycles inside of that, till you have a certain trust, or the model gives you the parameters that you expect, and you can move forward to, let's say, system acceptance testing, or UAT, and going on the production to monitor. There is a long way and lots of cycles inside of that. The CRISP model also represents this very well, that it's not like one shot that you prepare data, you learn model, you have an output, and that's it. At least, like Rolf shows you, is like 200 cycles for that, right? And additional challenges related to validation. So I could say the quality of a data defines the quality of the model. So as best data you have, the best model you get. And that's very important, because sometimes we think we have good quality data. And I think that the right assumptions on the beginning especially is that we don't have a data. We don't have a good data, even if you have millions of records. I'm brave enough to say we don't have a good enough data. Those data will be full of biases, different formats, different sources, different lots of things that will make that our model will not work. And through those cycles working on the model, we shape a little bit those training and testing and validation data. So we have a better model. We can adapt some parameters and get more and more robust results from it. SMEs involvement, I've mentioned about it. But SMEs involvement is more only than the people. There is also a time that you must give to data scientists to build a right model with the right parameters, and to make sure it's working as we want it, not like as we think it's working, right? Intended use, that's very important factor, especially in terms of validation, how you make sure that the system actually is working as we intended, as we wanted to use, right? Especially in regulated environment, that's the key of the validation, that you must prove that the system works as your intended use. So building maybe explainability to gain the trust, and to make it like from black box towards a white box, so we can explain why and how the answer is given, and based on what that can help you a lot, but it's only a fraction of all the things that you need to include in terms of intended use. The versioning, well, there are a lots of items to version, and it's not like a version of the code. and that's it. Also, the version of the data, the version of the model, version of the parameters, and everything. Are you using the right tools to allow you a versioning of that? One of the key factor here is to restoration. So if you figure out that the previous model was better, how you go back to the previous model? Do you remember all the parameters? Do you have the right data? Maybe you already cleaned those data and you don't have the right content of those data to retrain again, right? And even if you go on a production with the train model, and let's say that this, as example, like a static model. So after a while, you need to retrain a model. So are you going back to a training data and update them? Well, if you update them, you will receive a new model, a new version, and that may work totally different than the previous one. So it can be really lost through all those version of all the items that actually build your AI. And of course, very important topic is the monitoring the AI on the production and how this continuous improvement. So you can always find a new case, new risk, new problem with the AI, so you can learn more and improve the model. And of course, monitor if still works as you want it. And also Rolf shows a very good example if you are in the corridor of those good answers, and if you are like out of the corridor, something bad happens and you need to notify user that this is like a special case and be careful, right? And even like the notification to a user, please monitor or take a look on this data for me, those are suspicious. That's also a tricky part, how to make sure that AI will show you those data and based on what, right? And the clear guidance from the authorities for like, I know, a few months ago, I will say there is nothing. There are some blog posts, there are some information, but there is no like, regulation or exact guidance that you can follow and everything is there. This factor is still under the construction. There are some communication from health authorities, and I try to share with you. But it's like the beginning of the journey. They are interesting, they are learning, and they are trying to crash this topic because it's not easy. So from the validation of AI, the key focus points are like the intended use of the system, including the business continuity. So even if your system is working as you intended, what happens if the system is gone? Like if you realize that system is wrong, how you continue your work? Do you have another AI solution? Do you have another system? Do you have even people to step in and work, do this manual job, right? So it's really important from the business perspective. What is the intended use of the AI? How far the AI make a decision or even automate your work here? The second step or focus point is like validation strategy. Do you have a right validation plan and test plan for all those cases related to AI? It's in some degree it's very similar to the rule-based systems, but there are lots of additional things, additional factors, like all those new challenges and risks that you must apply in your validation strategy. Are you ready for that? Are you trained? Are you informed even about typical problems or challenges in AI to include this in the validation strategy and somehow prevent that, right? And of course, building a standard in the company. And are you ready for the audits? Can you prove that the system works as intended? Are you building the AI awareness across entire team? And I mentioned this many times. Data selection, how to select those data, right? A solution versioning that I've mentioned also before, and explainability. It's a big topic. And what methods are you using? Do you need to comply with the GDPR or not? And how, for example, one of the regulation need is that any user can request removing his data from your data source. And that means it's not only removing a data from a database, like this particular record, delete and done. He can also request removing his data from the AI that learns something. So how to approach this. It's a really tough topic in terms of GDPR in Europe right now, and how to meet the intended use in terms of the explainability. It's one of the method, I think, that having the explainability, you can prove that your AI focus on those portions, on those areas, and that's why that's the answer. So you can much easier prove that it's working as you intended. The security, well, in many times we need to deal with some health information or regulated records, and most of them are sensitive data, and including GDPR topics, but also in many solutions with the AI, you're storing your data on the cloud. Well, do you have right vendor assessment already prepared? Do you trust the vendor? Who's owning the data? What happens with those data? Do they have an access to your data, and so on? So lots of topic regarding the security. And you must be prepared for iterative development. It's not like a one shot, one iteration. There are lots of iterations, and for some of them, agile is like a right method maybe to use, but not necessary. In terms of entire system, you may still have a waterfallish approach, but still have many iterations in terms of building your AI modules. So it might be a very mix of different methodologies, I could say. And do you strive for the continuous improvements? Because I will show you some examples that you must, right? And innovations. Many times you need to deal with new technologies, sometimes even like open source solutions. So how you tackle those, right? How you are you prepared actually to work with such a technologies aspects in terms of validation? So jumping maybe to what you can start with is like writing your right question in the beginning, right? Gather some consideration, doubts, do the readings, and challenge and verify everything what your AI is doing. So you may prepare even a list of the questions based on the literature. Like, do I have a right resource, SME support, good data? Do I know exactly how to build it, and so on, right? Do I know any compliance needs? Many times you need to follow additional compliance needs. It depends on the area that you're building your AI. And there are lots of questions. I don't want to go through all of them. You may also start building your knowledge through writing some guidance inside of your company. A focus on one of the aspects and describing what is AI, how it's working, how we are going to use. So any new team member can read this and gain the knowledge from this, let's say, guideline, but that might be anything, right? So fun facts. And maybe I'll show you a few articles because in terms of the validation, I try to squeeze, I could say, like that, some knowledge. But I also would like to share with you a lots of materials, like external materials that are worth to read or worth to explore. One of them is why AI fails in the wild. So it's a nice article. I mean, there are lots of, and when you search artificial intelligence, there are lots of them. I'm not recommending this or that especially, but just to show you what you can find there. So on the beginning, for example, in this article, you can read that when artificial intelligence is deployed in the real world, it often fails. And I think it's so true because many times in the AI lab or in your test environments, it works perfectly with your data. But when you implement this into real world, then you can easily find out that there are really big flaws in terms of your model or data or training or whatever else that can goes wrong, really can goes wrong. So this is like a very basic information about AI, but there are a few things that I'd like to show you here. So one of the things is like optimizing the wrong thing. So many times when you are focused on the KPIs, and this example shows, if you're focusing on number of nails made, well, someone gives you a lots of nails. If you focus on the weight of the nails, you may have like 3 nails, but very heavy. So it's a funny example, but that also can show that when you're building AI and you focus on the parameters on the end that you would like to achieve, the AI will start working towards those KPIs, right? So having defined those KPIs, the outputs of the model may change your model to give you the right answer, and it's not necessarily the answer that you would like to get. It's like adapt to KPIs that you gave to AI. Optimizing with unrepresentative data. So there are lots of example in the internet how the answer is not right for you. For example, if you build a recognition between cats and dogs, right? And I mentioned that the answer is not deterministic. So from the neural network, you may have an answer like in 90% it's a cat. Well, you can introduce a threshold and says if there is more than 80%, it's definitely cat or definitely a dog, right? So you may see only the outcome like a binary outcome, but always it's like not deterministic. It's like probability. So when you have a weird picture, AI or neural network can be mislead. It's still a dog and everyone can recognize it's a dog, but AI may be confused. And what happens with those situations? Is it a really dog or cat, or AI does not know as we as humans understand. But if you give another picture, how the AI will behave. And here actually it's a nice example because you don't know how AI will behave, giving any additional random picture. It may says that it's a 100% of the dog. The nice situation will be if AI will show you like 50 to 50 that it cannot recognize. It's not a dog, it's not a cat, it's in a 50-50%. Then you can put any like a threshold or notification to a user, and if AI is not certain the decision, then you can post it and decide what's the answer. So going back maybe to my presentation and to other slides, another amazing, I could say, example, if the AI that solves the problem, is it a dog, like husky dog, or a wolf? And they was able to get AI that has accuracy like 90%. That was astonishing. But in some cases, it was wrong. So they start figure out why. And when they put, let's say, explainability, so AI can explain or show what was the focus of AI to recognize if it's a dog or wolf, they recognize that it's an amazing snow classifier, because whenever it's a dog on the picture, it's a snow on the picture, it recognizes that it's a wolf. And whenever the background is something else, like a grass, it's a dog. So even focus on one of the parameter like accuracy, you are not sure how that works exactly. So explainability makes here a lots of important role. Another example, like the patient with pneumonia and asthma connection. So there was some AI that was learned on many patients, many hospitals, and so on. But the story is that some of the patients with pneumonia and asthma was treated better than other patients because they were treated as a high-risk patient. They was treated with some medications and so on. And AI learn if someone has a pneumonia and asthma, it's a good situation, and try to send patient home. And actually, it's bad. It's very bad, because physicians could instantly recognize that's a very serious case, and they need to start the patient inside of the hospital and treat with some medication. But AI learns this only correlation between pneumonia and asthmatic and shows that that's a good thing, instead of it's a worst case scenario. So AI will never learn a cause of this situation. It learns about the correlation, and it's worth to be aware of that, right? And trying to explain, maybe nothing more. You can read. It's a really nice article. Another fun article that I really love to show is like recognition between a chihuahua and a muffin. So someone make some like a test and use different types of AI. And by the way, there are nice ready solutions, APIs. So even without coding knowledge on AIs, you can play around with available APIs to play around some different pictures and see what are the results. So basically, they are giving a picture and see through different solution what is the answer to classify the picture. Is it a muffin or a dog? And in some cases, it's a straight answer. In some cases, the AI was misled by nice pictures, right? And sometimes it's totally wrong. Like here, it's a brown and white teddy bear. Well, for even 2 years child, it's kind of like very easy to distinguish. Is it a cake or a dog, right? So for AI, it's still a problem. I mean, as long as you have right, good representation of data, um, uh, you may expect some good result, but still you can produce some pictures that will confuse totally your AI, right? And being on here like a competition, I'd like to show one of the example as well here. So imagine you have AI that is recognize what is on the picture. Like in this example, it's a bus, but you can put some kind of like a noise mask on the picture, and you can mislead AI, and later on it will recognize it's an ostrich. So for human, it's still a bus with some noise, and this noise it's not noticeable, but you can break AI putting a noise here, right? So someone asked the question, so how many pixels is a minimum to fool AI? And AI will recognize something totally else. And they come to a conclusion that only 1 pixel is enough to fool a deep neural network. And there are even like a competition, like 1 pixel attack. You can learn more. Under the link, there is a publication from the now from the science perspective, how that works. And exactly, there are some examples of pixels when to carefully select and put a change 1 pixel on the picture, so it recognized instead of a ship, it recognized it's a car. And as you can see, it's like 99% it's a car. Well, for human, it's really easy to distinguish. For AI, it's not so. Regulatory publications. So there are a few. I'd like to show you the first one, which is most recognizable right now from the FDA. Of course, it's in not the same area that we would like to see, like GxP. It's more in the medical device world, and especially software as a medical device. There were other like Century Cures Act or Digital Health from the FDA, and later on we had this discussion paper in 2019, really interesting paper, lots of good information about AI, not only applicable to software as a medical device. They have to crash the problem here, because they have something like 510K pre-market clearance. So every medical device must through either this pre-market clearance or de novo classification and other stuff here. So it's not easy to make new changes to your medical device. And whenever you would like to retrain your model and put again in the market, you need to follow some formal rules through the agency, which is not very effective. So FDA tried to crash this down and figure out how better we can optimize it. They proposed 2 solutions for that. One is that you can prepare like a plan of anticipated changes. You can prepare some risk of implementation of those, and you have like a clearance to move forward and modify on those areas when you define like how you're gonna change in the future. And recently, like 2 months ago or something, they've shared with us the action plan. It's like an update to an original discussion paper. Definitely worth read. Another case is like from the MHRA. There is a blog post and there is a guy who is explaining his interest and what MHRA is doing in health. They are focused on the three key areas. One of them is like cross-government work on artificial intelligence and cross-healthcare landscape work, and some internal MHRA work. So they are crushing what they are doing. And actually, the key message there is that they are still learning, and they are learning really good examples. So in a near future, you may expect that your inspector knows much more than you know from your company perspective building the AI, because they are gathering the knowledge from all the vast of the communities and real implementation. He also shows here a project about explanation, and there is a nice paper showing about the meaning of the explanation and the experiment, or the thing that with the public that they would do to see them the meaning of the explanation for a people. Definitely worth the read. Shows a lots of good information, especially in terms of, for example, the GDPR and how to address and how this explanation from the AI can be perceived by end user, and in what cases it's very needed and where it's not. And another publication that is very, very fresh is from Danish Medicine Agency. They don't have a lots of text here, but they like want to share in advance a draft, and they actually gathering still a feedback till end of April. And they have a list of the questions that you must be prepared actually during the inspection. I could read like that. So they are trying to help us as a companies to understand where there will be the questions of interest. And as you can see, the questions are not focused on the business side. They are focused on the data, on the validation, training, versioning, the numbers that you get from your RI, and some parameters. It's not like a 3 parameters plus F1 score. There are more, and they are proposing, they are asking about it. So it's really time to get the knowledge and start learning what is actually expected. And this is, I could say, so fresh, so good to see, because on many papers we can see a lots of interesting information. For example, here it's even the husky, Siberian husky and the wolf example, right? How you ensure that your test data are representative. That's very big question, and now you need to show to the inspector how you did ensure what you did to make sure that your company data, your available data, are good enough, right? Which is very tricky. So that's it in terms of regulatory publication. Now I'd like to jump into a Transtellarate publications. Because I'm a member of a Transtellarate, I'd like to also share with you some work that was done through the Transtellarate. So if you type like intelligent automation opportunities, you can find a web page from Transtellarate about that, and there are initiative solutions. If you click it, you will be navigated to a page like that with the 3 publications through Springs, and there is also a technology matrix showing how it was decomposed into different. Let me show you. Oh, I have it on there. Right, so the entire process was decomposed into different steps and was synchronized across different companies. That was a lot of work, and one of the publications that I show, one of those 3, shows exactly how that was done and what's the purpose and so on. So there are lots of good reading here in terms of pharmacovigilance work. But the good thing is that you can decompose the process, you can synchronize the process steps, and then have like a matrix of different technologies and see where different technologies are already like a planning or are as a pilot or already on the production, and you can get some information from this for your specific case, like can I apply this specific technology of, or if you're interested in automation of one of the step, you can see what technology was chosen or what is planning to be chosen in terms of this particular step. And I can easily imagine that very similar thing can be done, for example, for manufacturing, when you can decompose the entire process into different steps and do some analysis across different maybe companies or maybe across your company, and figure out where and how you would like to implement a certain solution. So there are lots of good reading here. I will not go through all of them, right? But there are really good slides and heat maps that shows a lots of effort that is behind those. The paper where I was involved, it was regarding validation of those intelligent automation systems, because it was called intelligent automation because it's not always AI. But the biggest problem, I could say, or challenge, is actually with the AI, because if you have a static or rule-based system which behaves based on defined rules, it's almost easy. But when you need to deal with AI, we identified and actually we proposed this classification in terms of validation into two AI groups. One is like AI-based static system, so you learn AI, it's learned, you can implement on the production, and it's working how you train it and test it and verify it, right? But there is also another portion of AI, it's like called dynamic or online or adaptive. So it's still learning on the productive data, and you will never know if it's still working as you intended. How to prove, how to document this, that's really challenging. And I think we as a entire world, we are not there ready to utilize, to validate such solutions like those onlines. There are some application, for example, military tried things which you can compare to a licensed pilot, where you can flight a certain number of hours with the AI, and then you build a trust, and then you maybe have something like a certification that your AI it's working. But you will never know, because every day can bring something new. And in terms of the validation of AI solutions, we have a lots of good materials like challenges and the focus points that you need to take under the considerations. Some of them I already mentioned, but definitely it's worth to read the entire paper, because I need to admit from my experience that while writing a publication, it's a lots of work from different people, and there are lots of challenges even to gather all the knowledge inside of the one paper. One of them is that if you focus and have different people writing different sections, and on the end you have a different story flows from different sections, so you need to have a lots of iteration within a team and other reviewers to make it, in the same level or the same degree of information, to target certain audience, to maybe compromise, because on the beginning our paper was very big, and even with the appendix, and there are some rules. If you would like to publish something, there are certain rules about how many words count you can have in the article. So we have to work a lot how to shape our papers here. So I need to say that under every of the sentence here, there is a lots of work behind that it's not seen. And I'd like to encourage you to read this very careful and try to understand what's behind. Our example for the validation is that you can base on the existing framework, like from the GAM, the V model. But of course, you can use any other models, and maybe you can play with the Agile or something similar. But we need to focus on another point where you are writing a published paper, you need to focus on something. You need to select, let's say, one target group so you can write and finish the paper instead of like trying to address every problem related to AI, right? So that's why this paper it's in a PV, because originally it's intelligent automation in pharmacovigilance, and it's about supervised AIs and so on. So it's not like a solution to validate any AI. It's in this specific context, but of course it can be adapted to any other areas. And we are also using or utilizing the FDA's materials. We proposing our, let's say, diagram, something that you can use to build your knowledge, your standards inside of the companies. Of course, we have a V model because we are in some we work also with a GAMP, and we try to use a V model from the GAMP and try to represent that in some way it's not so difficult to validate AI. If you focus that you have a planning, you have some requirements, you have all the AI related factors like data selection, model development, and maybe a more advanced diagram that Rolf shows you, like, I know half an hour ago, and then you have some testing and you have deployment, monitoring, and the production, and the circle can goes back to a planning and new requirements and so on, right? But in terms of like a basic concept for validation, it's not much. There are lots of work that needs to be done in terms of making sure that your AI system is doing what you expected. Like with the Husky dog example, how you make sure that your system is actually doing. And one of the key factor with the validation is to meet the intended use of the system. And from the testing perspective, like test data, test environments, test everything here, on the end, you may have even those evidences, but it's not enough. Like with the rule-based testing, you must adapt those, let's say, validation methodologies, and you need to understand and address new types of the risk that you have. You need to focus more on the monitoring. It's not like when you deploy them on the production, it's still working. You always need to have some kind of like loop back to see if it's still working. And there are lots of other stuff. I don't want to bore you here.
Pavel, just a quick heads up. So we are way, so 20 minutes more than expected. So it's nearly 10:30.
Okay.
Just to give you heads up. But I think at the end, all the material you have here, they can.
Yes.
Right? It's all on the internet available.
If you give me like 3 minutes or 2, I can finish, because that's the main content that I'd like to share with you. I have additional like other publications that somehow influence us or me recently, like the paper from Silogene. When you can use AI for some categorization, you can use AI or adapt acceptable quality limits from GMP into a pharmacovigilance, how to review or not review some certain outputs from a model, and how to optimize and utilize the SME involvement of the review of the outputs from every of those iterations from building AI. And there are also a paper from Pfizer that they also try to build some solution through different vendors, and to select a vendor, they challenge them and have different areas. They use the same set of the test data to compare them and try to select one of them. And on those both papers, there are lots of additional information, like how to deal with, for example, NLP, how they approach. There are some good, really, examples and pictures and diagrams from their analysis, and lots of materials to learn from. And there is also Royal Society saying more about explainable AI, but there are more. There are really more on this topic. Like NHS, artificial intelligence, how to get it right, also touches the problem of GDPR. There are materials for ARIS Global, also in the pharmacovigilance world, and they have very similar, like a life cycle development model for data collection, preparation, and so on, going through different phases. And there is a big topic like a deep learning that you can pre-train your models before you use in your certain case, and many, many more. That's hard to count. Okay, I'm done. Sorry for taking too much time. I thought you will ping me.
No, I didn't want to stop you because you were only at the very beginning. Sorry about that. And still a lot of people in the presentation, so I think it raises a lot of interest.